Hi, I am Arib. You are watching my YouTube channel. Earth Fault Relay. Definition: electrical systems require equipment to be protected for the safety of the device and the personnel handling it. The main constituent of electrical safety relies on proper fault detection and proper fault isolation. Modern electrical networks heavily depend on earth fault relays as one of their primary protection devices. Earth fault relays serve as vital equipment because they help identify unintended connections between live conductors and the earth. This blog is a detailed guide on earth fault relays as protection devices. It will define their structure, operating method, applications, and configuration methods for achieving dependable operations. Earth Fault Relay. The protective function of earth fault relays offers detection of any ground or earth-based fault conditions. The mechanism leading to earth faults originates from insulation breakdown, cable damage, and unintentional conductive part earth points. The main purpose of an earth fault relay is to detect earth leakage currents, which then activate a trip command to separate the affected system segment. Earth fault relays and their restricted variety function in all levels of voltage systems from low to high voltage. Different types of earth fault monitoring relays are installed throughout substations, switchgear panels, transformers, and generators to achieve complete coverage. Earth fault relay working principle: engineers and technicians must have a thorough understanding of how earth fault relays function. The functioning principle of these relays depends on detecting residual current flow. The total current flow in all three parts of a proper three-phase circuit maintains a zero value. The ground path operates normally until a fault occurs because, at that point, some current passes through it, leading to an asymmetry. A core-balance current transformer called CBCT detects the imbalance around all three-phase conductors through the earth fault relay. The relay activates its trip signal towards the circuit breaker when the residual current reaches or surpasses the defined threshold. The earth fault relay function thus involves continuously monitoring the system for leakage currents and acting swiftly to isolate the faulty section, preventing equipment damage and potential hazards. Earth fault relay works. An easy way to understand earth fault relay operation is to examine a basic distribution system. Under normal operation, the vector sum of currents in all three phases equals 0. The vector sum between all distribution system phase currents remains balanced until insulation failure establishes a current path between a live conductor and the ground. When the CBCT shows an unbalanced condition, the earth fault relay activates the trip mechanism. The relay protection system avoids the escalation of faults toward dangerous events, including electrical fires, component failures, and power system blackouts. The earth fault relay functions with modern technology to monitor in real time while showing digital displays that help detect faults accurately. Transformers and alternators require the restricted earth fault relay for zone-based protection to ensure fast and sensitive detection of faults, which are particularly critical in those areas. How to set earth fault relay? Configuring a protection system requires the correct setting of the earth fault relay, which is a fundamental task. The system protection settings depend on the voltage rating of the system, the type of earth connection, and the necessary protection sensitivity levels. Here are some general steps. The operating current settings will be determined through system fault current calculations. The scheduled time delay ensures selectivity between devices in an entire protection system as well as coordination between components that are downstream and upstream. The expected fault level should be slightly undershot in order to achieve accurate system performance through safety margin application. The relay settings for an 11 kV system typically use 20% of full load current and a delay of 0.2 seconds. Users can operate the overcurrent earth fault relay through front panel settings and communication interfaces in current digital systems. There are two recommended procedures to identify the specific earth fault relay calculation: consulting OEM manuals and utilizing software tools according to transformer types and load specifications. Earth fault relay calculation. Earth fault relay calculation enables engineers to establish appropriate relay sensitivity, which prevents false tripping and failure to detect genuine faults. The steps typically include: utilizing system impedance values determines the calculated fault current level. The selection of pickup current should be performed between normal leakage levels and expected fault currents. The implementation requires an examination of protection coordination between the relay and other protective devices in the system. Relays must function above 35 ampere since the maximum expected 500 ampere fault current requirements and 30 ampere maximum leakage current allow a trip setting value of 35 ampere using time current characteristics (TCC) curves. One can coordinate the time delay system for coordination with upstream devices. An earth fault relay may include a built-in calculator that simplifies configuration tasks for field engineers so they can set up precise settings accurately. Application of earth fault relay. Industrial, commercial, and utility infrastructures widely implement earth fault relay technology. These include step unit relays safeguard transformers, feeders, and bus bars within distribution power systems. The protection of generators and motors demands essential earth fault relays, which should be restricted or unrestricted. Substations use these relays for comprehensive monitoring and automatic tripping. Solar and wind power systems in renewable energy installations need sensitive equipment to detect ground faults. Critical infrastructure facilities require secure electric power through railways and airport installations. Earth fault monitoring relay. A contemporary earth fault monitoring relay is a protection element and a diagnostic mechanism. The device continuously tracks residual current values and stores background data in its system. Such monitoring assists in determining insulation vulnerability and supporting maintenance operations before breakdowns occur. Smart relays offer features such as real-time fault indication, event logging,